Today we are starting chapter 8. Our focus today will be to describe polygons. Before we work on describing them, we are going to need to remember how to name them. A polygon with 7 sides, what would that be called? A heptagon with a PT. 9 sides. A nonagon. 12 sides. Technically, there is a name for it. A dodecagon is 12 sides. Yes, just a plain decagon would be 10 sides. What about 42 sides? 42 gon. Not a gon, just 42 -gon. 4 sides. A quadrilateral, if that's all that we know about it. "50 sides. A 50gon. And 3 sides would be a triangle. Chapter 8 is all about more features of polygons. We will also be working a lot with finding area of polygons. Jakeem? Will we what? Not that I would expect you to draw, but I could ask you questions about it. Other questions before we get into our notes? All right. First keyword, convex polygon. This is one way we can describe a polygon. A polygon is convex if no line that contains a side of the polygon passes through the interior of the polygon. The example they show, first they show you a polygon. The second image is what you get if you were to turn all of the sides of that polygon into lines. So if we extend out all of the sides into straight lines, that's what they formed on the right side over here. So you can still see the same basic outline. And you can see that none of those lines go into the middle of the shape. So none of it falls in the inside. Questions about what it means to be convex? We will compare that to a concave polygon, which simply is not convex. You could think of it as having dents in it. Some people call it caving in on itself. You'll know for sure that you have a concave polygon if you go to extend one of the sides into a line, and that line goes into the middle of the polygon. It only has to happen one time, and that automatically makes it concave. You'll notice that not all of the lines go into the middle. For example, if we were to extend the bottom line of this polygon, that bottom segment, that one doesn't go into the middle, but because this other one does, that makes it concave. So before you try to call something convex, make sure you've checked all of the sides to make sure none of them would go into your figure. Equilateral and equiangular we've talked about in regards to triangles, but it will also apply to polygons. An equilateral polygon has all sides congruent. An equiangular polygon has all angles congruent. A regular polygon is both equilateral and equiangular. So all sides are congruent, all interior angles are congruent. For it to be regular, it does also technically need to be convex. So convex only. We would not consider concave polygons to be regular. All right, our first one, convex or concave. Convex, if we extend all of these sides, none of them ever cross into the middle of the polygon. So this one would be convex. All right, what about the one next to it? Concave. Some of the lines don't go into the middle, but at least one of them does. So because this one over here goes into the middle of the polygon, it has to be concave. All right, what about on the bottom left? Concave again. Some lines don't pass through, but we've got a couple that do. So because that one goes into the middle there, it is concave. What about the last one? Also concave. Again, some lines are just fine. Other ones, like these ones on the side here, would go into the middle. So even if just one side would cut into the middle if you extended it, that makes it concave. Questions, concerns, need more time with these examples? Okay. Determine whether the polygons are equilateral, equiangular, or regular. On example 5, is it equilateral? Yes. Is it equiangular? Yes. If it's both of those, you have to call it regular. So if this were a question on a quiz or a test and you just told me it's equilateral or you just told me it's equiangular, you would still get it wrong. Regular is the most specific way that we could describe it. On example 6, is it equilateral? No. We have pairs of congruent sides, but not all of the sides are congruent. Is it equiangular? Yes, it is. Could we call it regular? No. It has to be both equilateral and equiangular, and it was not equilateral. So we can only call it equiangular. It's not equilateral on this one. So you have pairs of sides, but not all the sides are the same. So for equilateral, they all have to be equal. Other questions about 6? Okay, by looking at 7, how do I know right away that it can't be regular? They didn't mark the angles, but even more than that. How else could I describe that based on the problems we just did above? This is concave, and if it's concave, it definitely will not be regular. Okay, so make sure you're looking out for that. It's not regular. They didn't mark the angles anyway, so the only thing we could call this is equilateral because they did mark all the sides the same. It's possible for a polygon to be none of these things. Okay, it's possible to draw a polygon that's not equilateral, that's not equiangular. They just didn't give us that option here. Questions about equilateral, equiangular, and regular? Okay, make sure you're able to spell these words. If you can't spell them, you're not going to get it right. Okay, I don't think they're all that hard. We are told that these polygons are regular. We are asked to find the value of x. If they're regular, what does that mean? What's congruent? The sides are congruent and the angles are congruent. In this case, we don't care a whole lot about the side or the angles. We just care about the sides. So if all of these sides are the same, what could I do to solve for x? Good. We could set two sides equal to each other. And to solve it, we would need to do what? 6x equals 24. Then we would x equals 4. Okay, same idea on the next one. If it's equilateral, all the sides are the same. So our equation would be x minus 3 equals 15. To solve it, we would add 3, x equals 18. Questions, concerns? Okay, we'll keep it moving. Again, these are regular. Same kind of problem as before. All the sides are the same. All the angles are the same. So what would my equation be for example 10? Good. To solve it, add 4 and then divide x equals 5. Last one on this slide, our equation would be good. To solve this, careful, add 2. Okay, so 11x equals 110. Then we would divide x equals, x equals what? 10. Questions, concerns? Okay, usually the first lesson of the chapter is pretty easy, pretty straightforward. We'll build on that tomorrow.